Hi, my name is Robin Brown, and I'm in session 30E of this middle grade statistics course through the West Virginia Department of Education. I'm going to walk you through a CRA model titled Solving Jenna's Homework Problem with the Mean and MAD. And I'm working with West Virginia Standards M.6.26 through M.6.29. So we want to start students off in the concrete phase, where they're given a list of numbers. Jenna's collected 2 weeks worth of math homework problems, how many she had. So that'll be a total of 10 pieces of data, and they're listed in random order. The teacher will actually give the students a chart that looks much like this, but the numbers of homework problems will be listed in this random order. So we want the students to work with the numbers physically and manipulate them. They can draw their own chart with pencil, paper, and a ruler, or make their own spreadsheet. And we're going to ask them to list the homework problems in order from least to greatest. So hopefully they get more familiar with the numbers and see that some of them are small or repeat, while some of them are actually much larger. That we're always comparing them to the mean, which is 9. And that when we find the absolute deviations, we're always subtracting each piece of data. We're finding the difference between that piece of data and 9 and taking the absolute value of that. So whether the answer be positive or negative, we actually only want the total distance from 0. So the answer will always be 0 or a positive number. And they might see that those answers don't actually go from least to greatest, and that some of those answers are small while some of them are quite bigger. And we just want them at this point to get familiar with how you actually do absolute deviation, having seen the teacher model, and then having retyped the information or rewritten it in their own graph. Seeing the information more than once will help them solidify what absolute deviation means. And then we want to move students towards a representational graph stage with a dot plot. So this is a little bit more abstract because the dots represent the numbers themselves. And we want to help students see, without doing the mathematical calculation, that the mean would actually be somewhere in here between 8 and 9, close to where my dotted blue line is. And that's because there's 1, 2, 3, 4, 5 dots representing data on the left side, and 1, 2, 3, 4, 5 numbers representing, or dots representing, data on the right side of the middle. So that would be my fulcrum, or middle of my scale, where I would balance it. So it would be between 8 and 9. Then when we actually do the math, they'll see that it's 9, or they'll remember that from the chart that they just did. And we want students to draw arrows. I did green going right and orange going left from the mean, or the middle, to these individual dots. And they can see that there's 5 arrows going right and an equal amount going left. And they can also see that some of them are much shorter while some of them are quite a bit longer. That actually will help them conceptualize what the MAD is, or the mean absolute deviation. So the mean absolute deviation is how far on average all the pieces of data are from the mean, the middle, or the average. And so the larger the MAD, the more variable the data is, and the smaller the MAD, the less variable the data is. So that's used in collecting data or the scientific process. The less variable the data is, more reliable it is, the more consistent the information. The larger variability in the data means that there's less consistency, and the data is less reliable, and perhaps a larger study with more answers, a larger sampling, should be done to get more accurate information. And then we want to move students into the actual abstract and formulas phase of figuring out the mean and the MAD. So for the mean, we'll have them add up all the pieces of data, which totals 90, and divide by 10, because that's how many pieces of data there are, to get us an answer of 9 for the mean, or the average. And the mean absolute deviation, we'll take each of those pieces of data and subtract 9 from them. And we'll take the absolute value of those answers. So even if they're negative or positive, we get the number itself. It has to be 0 or essentially a positive number. So we'll add up those 10 answers and get a total of 72, and divide by those 10 answers to get 7 2/10 for the MAD. So 7 2/10 is actually quite a bit of variability in homework problems, and you might tell students we're going to round this 7 and 2/10 down to 7, because in this real world situation, a teacher is not going to assign 2/10 of a homework problem. So we can subtract 7 from 9 and we can add 7 to 9. So her homework will be between 2 to 16 problems a night, and that's actually quite a bit of variability. That's like basically almost no homework versus quite a bit of homework for math. So it's going to be difficult for her to predict how much homework she might have. That's a lot of variability. And then you might ask students or further explain why there might be so much variability in her math homework. And you might say something like, when you get to the middle of a lesson where students have been practicing this material with the teacher and independently for a while, they might have more homework problems for more independent practice. The gauge of if the students understand versus when you get to a day before a test, you don't want to give very many homework problems because you want them to review vocabulary and study guides, previous homework pages, so you're not going to assign a lot of homework problems before a test. And that might factor into some of the variability in her homework. So I hope this helps you conceptualize how a CRA model might look for teaching students the mean and the MAD. Thank you for watching.